Okay, so we've got page 368 out of your packet. There's some problems there I had to work on. I'm going to take a look at, we kind of did one like number 3 yesterday. So I want to take a look at number 4. Did any of you get an answer for number 4 yet? I'm exaggerating my angles a little bit here just because I'm horrible at drawing stuff. This is 38 across here and 38 across here. Radius of 43.8. Height of 97.5. Center to center, yeah, this is page 368. This is 101 and 202, so it's dead center. They want us to find here that angle. So right triangles for us. Well, we can do this one, the radius to a tangent. That'll be a right triangle, or right angle at least. The other one that we should have, we can have one here that is a vertical and a horizontal. The question is, where do we put them? So what can we learn from? I gotta draw that correctly. 97.5 was just that. And all the way up is 143.3. So anyway, looking at this drawing here, there are actually some dimensions I can draw in. What I'm going to do is I'm going to try to do this. I'm going to draw in this triangle. You might ask me why? Well, because that's the only triangle I can see there. It has a vertical dimension and a horizontal dimension. Any of the other right triangles I was thinking about drawing in, I didn't see any way that I could actually find their angles or their sides. Here, I know this side is the difference between those two dimensions, right? So what does that come out to be? 4580? $45.80, perfect. And then this dimension across here is the difference between the 101 and the 38, which is what, 63? So I can find this distance. That's just going to be, I'm going to redraw my triangle here. You got it. 45.8 squared plus 63 squared, then square rooted. Let's get back here. Sounds right. 77,889, we'll call it. So we've got that distance. We can find some angles here. I'm going to find, well, let's find this one. Just because. So what am I going to do with that one? Well, that angle will be, I'm going to use the ones that I calculated by subtraction because this one's rounded, isn't it? So I'm going to use those two. Yeah, so I'm going to use the tangent of an angle is opposite over adjacent. From that angle, this is the opposite side, this is the adjacent side. So I've got 63 over 45.8. Am I looking for an angle or a side here? Looking for an angle. When I look for an angle, I have to use inverse. So I'm using a tangent, so I use an inverse tangent. So the angle is the inverse tangent. Perfect, 53.98. That's 53.98 degrees. Now what this triangle does for us is now it allows us to look at this triangle with this right angle. And this is the hypotenuse. Let me draw that triangle. This is a right angle. I know this is the radius, the 43.8. This up here we calculated to be 77.889. Now, all I really need off of there is this angle. That angle, this is the opposite side. This is the hypotenuse. That angle, opposite hypotenuse, is going to be sine. Yes, so fill in the information. Sine of the angle is going to be the opposite of 43.8 over the 77.889. And yes, we are going to do an inverse sine because we're looking for the angle. 34.218. Okay. So what that tells us is up here, this angle right here, from here to here, is the difference between this angle and this one we just found down here. Because the 53.98, that's this angle here, right? If we subtract out this angle, that leaves us with this one. Why do we care about that one? Well, let's find it first. So 53.98 degrees minus 34.22, we'll call it, is going to give us 19.76 degrees. This angle being 19.76, we can now find y here, because this is a right angle, we subtract the 19.76 to get that y is 70.24 degrees. So we had to find an angle bigger than the one we wanted and then subtract a piece off to get to where we needed to go. That's why these are called complex applications. Because you have to find a right triangle to get the information you need to find the right triangle you want. Okay, so I'm going to redraw this whole big thing here, right there. This is what I have, and I am looking for this angle right here, y. I found a triangle that looks something like this, right? This angle was that 53.98. Well, that includes part of y. If I looked at this right here as being a right angle, y is the complement of this angle right here. If I knew that angle there in brown, I could just subtract it from 90 to get y. Does that make sense? This is a right angle, correct? So y plus this angle adds up to that right angle of 90. So I need this brown angle here, but that's not what I found. I found this big thing here, right? So to get back to the brown angle, I need to find this angle and subtract it off. So that's why I went next and I did a triangle that looked like this. And in that triangle, I found this angle, which was the 34.22. Yeah. So I've got this angle that's 53.98, this one that's 34.22. Subtracting gives me that this one is 19.76. Yeah, so then we go back to the bigger angle. That 19.76 is subtracted from the whole 90 to leave us with y. Yeah, there's a lot of little pieces coming together all at once. Okay. I want you guys to try number 5 quick. I'm going to give you a few minutes, then we'll talk about it. Okay, well, let's see how this thing's going. One thing you'll notice we're not given here is a total height. But we can find the height from here. Try a different color there so it shows up a little better. The height from here up to there. How? This little triangle right here. We know this dimension is the difference between 2 and the 0.975. This is 1.025. So if that's 1.025, we know if I do this, if I connect this, this is a vertical, so it's going to be a right angle here. And we know this angle is half of the 6720, which is going to be 3340, right? $33 degrees, 40 minutes. 0.66666, correct. So that makes this one here 56 degrees, 20. So we've got that triangle. I'm going to redraw it out here. (56 degrees, 20 minutes), right angle, 1.025. Going to call this side A over here. To find side A, what sides do I have? Well, this is my angle, so A would be the opposite. 1.025 would be the adjacent, which is tangent. Filling in what I know, we have 5620 equals the opposite of side A over the 1.025. We're looking for a side or an angle? Side, so we're going to cross multiply and divide. So we're going to go 1.025 times the tangent, 56 degrees, 20 minutes, divided by 1, of course, is 1.539. So this height is 1.539. Now, of course, from here to the top of y, if we put the y with the 1.539 dimension, is the same as from the bottom of the V to the top of the round stock. Well, I know this dimension is 0.75. Where'd that come from? Yeah, we gave you a diameter here instead of a radius, so it's half of that 1.5. All we need to do is finish off this purple triangle here, the right angle. So let's look at that purple triangle. So we know this is 0.75. We know this angle here, we found that to be 3340. We are looking for, let's call this dimension here dimension B, that's that vertical. The hypotenuse of that triangle, I'll label hypotenuse. The 0.75 is which side? Opposite. So that is the sine of theta. Opposite of our hypotenuse. Do we know the angle? Yes, that is the 3340. Do we know the opposite? Yes, that's the 750. It's the hypotenuse that we're looking for, so we are looking for a side. We'll put this over 1. We will cross multiply and divide. So 1 times 0.750 is 0.750. Divided by the sine. 33 degrees, 40 minutes. Giving us 1.353. So this is 1.353. So that total height from here up to there, 1.353 plus 0.750. The worst times. 2.103, right? Which is also the same as this over here, the 1.539 plus y. So I subtract 1.539. Should leave me with y. 0.564. Does that look right? That I believe is in inches. So not so terrible. Not so great. Well, I am going to leave you with this set of problems for the last 20 minutes of class today and for over spring break. Page 368 through 371. There are some fun ones in here. Like number 12 is an even numbered problem, but that's kind of a fun one. Number 9 is the little roller coaster thing. At least that's how I think of it. 13 can be a lot of fun. Like I said, there's plenty of fun to be had by all here. It'll give us something to talk about on Monday when you guys come back from spring break. So let you guys have the last 20 minutes to work on those.